Now we will check the answers to the practice problems. Alright. So your problem here, that quarters had weights that are normally distributed with a mean of 5.67 grams and a standard deviation of 0.062 grams. Okay. So this time, if 160 quarters are inserted into the machine, what is the probability that the mean falls between the limits of 5.55 and 5.79? So here, just like before, our mean is 5.670. Our standard deviation is 0.062. Our sample size n, we're looking at 160 quarters, and we want the probability that the mean, so this time we use x bar, is between 5.550 and 5.790. So this time we do have to use our newer formulas. Alright, so using the normal CDF function on the calculator, we enter in the minimum, 5.550. We enter the maximum, 5.790. We enter the population mean, or the mean of our sampling distribution, because it's the same. And we enter the standard error, which is the population standard deviation divided by the square root of the sample size. Now, when you type this into the calculator, an interesting thing happened. It equaled 1. It's very likely that the mean of 160 quarters falls between 5.55 and 5.79 grams. Right? It's not exactly 1 because that would guarantee us, so we don't want to use that language because there is still a possibility that it won't be in there, but it's extremely close to 1. The calculator didn't even give us scientific notation or anything, it just gave us 1. And for problem number 5, now we're looking at a ski gondola in Vail, Colorado. It carries skiers to the top of a mountain. It bears a plaque stating that the maximum capacity is 12 people or 2,400 pounds. So that capacity will be exceeded if 12 people have weights with a mean greater than 167 pounds. And we get that 167 pounds just by taking the maximum capacity divided by the number of people. Right? So if each person weighs 167 pounds, that will be over the weight limit. So because men tend to weigh more than women, a worst case scenario involves 12 passengers who are all men. So men have weights that are normally distributed with a mean of 172 pounds and a standard deviation of 29 pounds. So we have a mean of 172, a standard deviation of 29. Our sample size is 12. Right? So we want to find the probability that 12 randomly selected men will have a mean that is greater than 167 pounds. So we want the probability that x bar is greater than 167. So if we use our calculator function, we use normal CDF, our minimum is 167, our maximum is 10,000, our mean is 172, and our standard error is the population standard deviation divided by the square root of the sample size. Right? This gives us a probability of 0.7248. So this is 72.48%. So there's a 72% chance that the average weight, if there's 12 men in this gondola, will exceed 167 pounds. That's kind of scary. This is not good. All right. Chances are when that gondola was built and that plaque was put in there, the mean weight of the population of men in this country was less than what it is now, less than the 172 that it is now. So they should probably reevaluate the gondola, either check it out and see if it can handle heavier people, or lower the suggested number of people. Okay. So we will take a look at some more problems in class, practice this up some more, and your quiz will be coming up in just a couple of days.